Okay, so now that we've dealt with assertions, where we've kind of hopefully become comfortable with the stuff we had to deal with here, let's add a new token type. And so the next token type is going to be atomic. So atomic, I guess groups is what I'll call them, is stuff of this form, right? Some junk in here. So atomic groups, I can't think of what else to call them. Captures are things that just throw away backtracking information. So once it's matched whatever its token is, it will consume it, excuse me, and then it's going to throw away all the backtracking information and move on. So you can't backtrack into one, and for that reason we'll need to store enough state that when we get backtracked into, we can reset. But as soon as we've matched, we can immediately throw away all the backtracking info, which means we're just going to wipe the stack. Okay? So let's go ahead and add a class, and it is going to be called atomic. And I'll put it over here. And this guy is a subclass match single base, right? And once again, we will implement the class. And I'm going to, whatever, I'll just do the can constructor thing. Nothing new to contribute to this. Okay, so the match, well, let's keep track of all the stuff we gotta keep track of. Let's keep track of the offset, context offset. Let's keep track of the current key, context.key. And let's keep track of the stack size. Stack size equals context.stack size. Okay, once again, we can just set our result equal to the match item match result on our context. And then immediately we can restore the stack back to stack size because it's atomic. So once we're done, that's not the right character. Let me coalesce that. So because this is atomic, we immediately lose all backtracking info. Now, if we've succeeded, then I need to store some backtracking information, which I just said we threw away. I need to store this information so that when the atomic token is backtracked into down here, I can reset everything. So this is the first time we're going to keep multiple pieces of information. So context.push, and arbitrarily I will say, let me save the key. And in this order, I will push the key and the offset, right? And then we will return the result. So if we fail, then there's nothing there. This is restored and nothing's happened. If we've succeeded, we need to keep track of the key and the offset so that we can unroll anything that's been captured and push us back to our starting position. Now let's come back here, and I can tell you one thing. This is not going to have another option, so that's definitely false. I will say int offset equals context.pop, and obviously I'm doing these in the reverse order because it's a stack. Key equals context.pop again. Pop those guys back off, right? Key, offset, offset key, just making sure. And then I can say context.restore capture stacks based on this key, and context.offset equals this offset, and then fail. So that's it. That should be an atomic match. So let's just get to getting and make a test. Public static void atomic test 1 sounds epic. And I do have kind of a good example here. Let me pause and go find it. Boom, pasted. So this big old beast is going to be the thing that we're going to build. Okay, so first of all, I can throw the outer captures away. That was from my notes. That's the entire regular expression. So this set of parentheses here around, well, I guess I can just go inside out. So we're going to match the character A 2 or more times atomically, right? So once it's captured, it's captured. And sorry, not captured, that's a horrible word. Once it's consumed, and that's the end of the story. Because this is not a capturing group, I'm just explicitly wrapping it in a capture group so we can look at what the atomic match actually matched. And then there's going to be a non-capturing group here, which is the alternation, either A or B. Okay, so this is what we're going to build. So var context is a new context on the string AAAAB. Sounds good. Var char A is a new character for A, and I will go back on what I said and copy paste because this is pretty easy. And what do I need? I need a var, let's call it greedy. I'll call it greedy 2A, and that's going to be this. Is new greedy of char A 2 or more times, and var atomic equals new atomic on greedy 2A, and var cap1 is the new capture group on atomic, and that's group 1. And then I will need this alternation, right? Var, maybe I'll make a little space here, var alt equals new alternate, and this is new iMatch array, whoops, which contains first char A, then char B, like so. And then we need the token, which is the list of those two. New list of new iMatch array of our first capture group followed by our alternation. Like that. Okay, I think that's what we want. So let's try it. Exec test on the token on this context. And let's go put it back here like that and run it, see what happens. All right, it seemed to have worked, but did it work? Okay, well, we matched successfully. The stack now contains, let's see, 0, 0, 1. Regular expression matched the entire thing. The first group, which was the atomic portion, matched the sequence of A's, which makes sense, right? 2 or more of those. So we consumed all of the A's. And then this was atomic, so we threw away any information about how many we stored, which is why the 2 optional additional ones have now disappeared. But what did I store? I stored the key and the offset in that order. So the key, which is how many capture groups were present when I started, none. And the offset, which is where did I start atomically matching, which was the beginning, are now stored. And then after that was the alternation, for which the second item, right, in slot number 1 matched. And so this looks correct. I backtrack, I have no other options for B, and then it's atomic, and the whole thing unfolds. Okay, so that appears correct. Let me now make the following change. So I will, for the sake of argument, put an A right there. And I'll just add char A like that. And I mostly wanted to do this so I could see the key is still 0, the starting offset was 1, and everything else is the same, right? We captured index 1 through 4 inclusive, blah, blah, blah. So, okay, so that's atomic matching. And next we will do effectively atomic matching again, but this will be possessive. And it's really an atomic greedy match. So that's next.